We'll be talking about AWS organizations today and centralized alerting with CloudWatch. Many AWS organizations have a pretty cool CloudWatch setup, have structured logging, you have your metrics, and you get your traces in X-ray. But one thing that often falls apart in my perspective, especially once organizations and teams grow, is to have a central approach to all of that. One example here are CloudWatch alerts. If you have different developers and different app teams, for example, who are working in their own isolated AWS accounts, you often have the issue that they need to set up CloudWatch alerts and also need to set up all the actions where the CloudWatch alert results should go to. For example, you need to authenticate with Microsoft Teams. You need to set up a custom application with Slack, or you use Amazon Q chatbot, or sometimes use SCS or some verified identities, or simply the email service within CloudWatch directly. So there are many things you can do after a CloudWatch alert goes from OK to an alarm, and I think a centralized approach here is the best one. And in this video, I show you how to build such a centralized alerting system. I have source code with me, CDK code with me, so that you can deploy it in your own organization, and we'll build a small example app so that we can see how that works out. I'm Sandro, and I am building AWS infrastructure for different clients, starting from startups, going to scale-ups, and also in enterprises. I've used different architectures and different patterns, especially on the CloudWatch and observability side, to do that, and I want to show you today how we can build that. So what we are building architecture-wise today is this kind of architecture. We can see we have an AWS organization, which is the big orange box here. We have three types of different accounts. First of all, we have a management account. In this management account, we deploy CloudFormation StackSets. CloudFormation StackSets are simply CloudFormation stacks that you can distribute to different organizational units or different accounts in your organization. Then we have our app accounts. In this case, our app account is simply an account where some application lives in. So this is typical for a multi-account organization in AWS. So let's say here, for example, some internal CRM is running and here some API is running, for example. We deploy some event rules into these accounts. We see them more in a second. So this is the second type of account, and the third type of account is our observability account, and this is actually the central hub we have. So all events should go into this account, and from this account we steer and we control the alerts. In that case, we send them to Lambda and then we send them to this. The final result will then look like this. We have a central alert here. In Discord, we simply get a message that an alert arrived, and this actually went through two AWS accounts through the Lambda function into the Discord server. So here we can see our typical AWS organization. We have a root account, we have a development UU, we have a production UU, logging account, and the management account. The management account in that case is simply named Sandro. And in these organizational units, we have different accounts in there, and this is where we deploy our StackSet to. We want, and now with we, I mean, for example, the platform team. So we want to give developers and enable developers to build their stuff faster, but also to run their applications faster. And developers know the best which metrics they need to look out for, because they can look out for some standard metrics, 500 errors, Lambda errors, and so on and so forth. But they can also, since it's CloudWatch, simply emit some custom metrics and look at some business values. If some import failed, if some values are over certain thresholds. So basically everything you can emit to CloudWatch, you can create an alert on. And we simply want that the alert actions are centralized and more flexible. So the flow looks like that, and the idea looks like that. So we have a CloudWatch alert. The CloudWatch alert natively emits an event to the default event bus of AWS. So each AWS account comes with a default event bus, and CloudWatch, once the alarm changes from OK to an alarm, and also vice versa, it emits an event to the default event bus. And what we are doing then, via the StackSet, we deploy an event rule. And this event rule forwards exactly these events to a custom event bus in our observability account. Of course, this also needs to be set up. This is also what we're doing together. after we arrive in this custom event bus and after we get a CloudWatch alert, we have a Lambda function as a target on top of this event bus. So we attach a rule to that as well. And the Lambda function is doing some custom code. You are very flexible here. In that case, I simply have a Discord notification. So let's build it together and look at some code. We have published a GitHub repository where you can exactly use this code and deploy it. The first thing you need to do is going into the environment config. So we have a type safe config here, and replace these placeholders. You need your management account ID and you need your observability account ID. Then you need an ID of your organization. The whole setup only works with an AWS organization. And you need your target organizational units where you want to listen to alerts to. And in the end, if you have a Discord webhook URL, you can put it in here. Discord is free, so it's easy to test it out. I've hard-coded the event bus name here as centralized alerting event bus. You can use whatever name you want, and I used it here in the config because I don't like these cross-stack or cross-construct references that typically add some cyclic dependencies and simply don't work out. So I now fill up these parameters for a second, and then we can continue. After you fill them up, we can go through the code a bit. So we have two stacks to deploy. First of all, we have the observability stack. The observability stack is everything which is deployed in this account. And this is the event bus and the Lambda function, which then talks to Discord. The second stack is the management stack. And the management stack is what is deployed in this account, which is the CloudFormation StackSet. And once you deploy this, you automatically deploy it to the organizational unit you defined. So for example, into these two app accounts. And that is basically it. We don't have anything more. All right, so let's deploy this together. You cloned the repository, you filled up all of the account IDs we need, and now we can deploy it with CDK. The first thing you need to do is, if you haven't used CDK before, you need to use CDK Bootstrap. I did that already, so I don't need to bootstrap my accounts again. One thing which is very important is in which account you are currently logged in, because we need to deploy things in two different accounts. If we now look, so my alias for PNPM is PN, not that you're confused of that. If you now look at that, we have two different stacks here. We have the stack centralized alerting observability and centralized alerting management. We first deploy the observability part so that this is already ready before we deploy everything into our app accounts. So I activate now my local profile for my observability account. I use Leap for that. And now I simply go in and say pn cdk diff for now alerting observability. This will show us the CloudFormation diff on what will actually be deployed. And we can see we deploy an event bus, a policy, a role, a function, a rule, and some other permissions. So this is what I want to do. So I go in there and say cdk deploy centralized alerting observability. This will now deploy the stack into my AWS account. I need to approve that. And after that is done, we will go ahead and deploy the stack set. Well, first of all, we will look into CloudFormation and see how it's going. So in CloudFormation, we can see the centralized alerting observability stack. We see it is deploying at the moment. We can look at the resources. We have the event bus, which is already here. So if we open that up, we should see an event bus, even with a rule already. The rule is defined as the CloudWatch alarm state change. So that means everything that comes in from the source AWS CloudWatch and the detail state value. So this is the value the event changes to, so the alarm changes to. If this is alarm, this rule triggers, and the target of this rule is a Lambda function. And if we look at this Lambda function, we see EventBridge is connected, and this Lambda function is handling the call to Discord. So we can see here actually the code as well. So basically it is just doing a fetch to Discord URL and API, and that's it. So let's look at CloudFormation again. We see it is completed. So we now have all resources available. So as a reminder, I'm talking about these resources. These two resources are now there. Next, let's go to the management account and deploy the stack set. For the stack set that you can deploy it, you need to enable trusted access to the whole organization, because we are now from the management account from CloudFormation deploying something to the whole organization. I did it already, so I go ahead and deploy it now. First of all, I change my local environment, so this is on another screen. So my local environment is now, so my AWS profile, my default profile is now pointing to the management account. You can also use different profiles for that. For this simple case, I just switch it around. And then I go ahead, say pncdkls, just did I know the name again. The name is centralized alerting management. And then let's also make a diff here to see if it's already available or not, but I just destroyed it, so I know I just deployed a stack set here. And then we go ahead and say pncdk deploy centralized alerting management. So if we look into that again, into the management stack, I simply build a pretty simple template. There's also a CDK construct for building these stack sets. For now, this was simpler to simply put the rule in here, the resources. It's not 100% type safe, so you can also do it different. Feel free to do that. But in the end, I used the CloudFormation construct CFN stack set, put it onto the target organizational units I've defined. Typically, this is the development or the production organizational unit. Typically, you would also handle these a bit differently. And this deployment can go on for quite some time. So especially if you have many member accounts in there, you need to imagine that we not only deploy this in the management account, but we deploy in the management account and tell the management account to deploy it in all member accounts in the organizational unit you defined. So if you have 100 accounts, you don't wait for one CloudFormation deployment, you wait for 100 CloudFormation deployments. And as you can see, we have some concurrent accounts, some concurrent count here. So you can make that faster or slower, however you want. You also have a failure tolerance here. But for us, I just have one account as an example in here in this organizational unit. So it should be fairly fast. So now we can see it is deployed. It took over 100 seconds, so still okay-ish, but like I said, I just have one account in there. And now if we go back into our management account, we will see that we have this stack set. So let's have a look into that. So now I'm in my management account and I can see centralized alarm forwarding. I see that this is actually deployed now in an organizational unit. And what I can do now is I can create a CloudWatch alert in one of those accounts, and this is what I'm doing now. All right, so now I'm in a member account here, and I want to go ahead and create a CloudWatch alert. So let's create some alert here. Let's create it on the metric invocations of my actually new event rule. I give it some number, it really doesn't matter at all. I even remove the alarm action because we don't want that developer set these alarm actions. We want, as a platform team, we want that we set the alarm actions for them and have some defined configuration. So let's give it some name, test alert, and that is it. And it is created. And now what I'm doing is I go into Cloud Shell and I copy the command here. Because now I want to set this test alert into the state in alarm. So what I need to do for that, I use the CLI and simply say AWS CloudWatch set alarm state with the alarm name. And the alarm name is test-alert, state reason testing, state value alarm, region EU Central 1, that shouldn't matter anyway. Then we hit enter, we reload here. Now we see in alarm. And now if I go to Discord, I assume that I already have a message in there. And like I said, here is the new message, CloudWatch alarm test alert from this account in this region with a description and some additional data. You can make this message much nicer, of course. Now that we've seen the overall setup of the idea of centralized alerting, this is how it should look like. We have app accounts which are emitting events to the observability account. But we can take it a notch further, because if you have this problem, you probably have multiple accounts and you also have the need for some more configurations. So there are three things I would recommend what you should do. First of all, use some batching. If you have multiple accounts and we have hundreds of alerts, it can get quite expensive with this approach. So what I would say is use SQS. Of course, we want to fill this up. Use SQS here in between, because you get so many alerts in there. You want that your event bus puts everything into SQS out of different reasons than batching, but also for batching. Then you can batch them and then you can give these batches into your Lambda function. So then it would actually look like this. SQS going to Lambda, and then Lambda works on it in batches. For example, it depends on how fast you need these alert notifications. You can have batches of 10, for example, in a short polling window, so that you can work with that. Second part, I think not every alert should be treated the same. Let's say you have a user sign up form and there's a specific username you need to enter, and if the username already exists, you get a 400 error. These errors are expected, so it is fine if the errors come up. It is still fine to have an alert on that, so you can have an alert on 400 errors, for example, if they're elevated in relation to your requests. But this is typically also, I would say, not a major incident where you need to get called out of bed and stuff like that. But if your 500 errors, especially in relation to your requests, are increasing a lot, then this is probably something went wrong in the deployment or something else failed. Typically your database died. Then you should probably be called and be woken up. And this is why I would say what you should add to an alert is a severity. For example, you could say each CloudWatch alarm has a tag. In this case, we have a tag, and this tag is called severity. And this can be of the value high or low. If the severity is high, we can handle it differently compared to if the severity is low. This could be done in the Lambda here. If it's high, we could call PagerDuty or we could create a ticket in Jira. If it's low, we simply send a notification to Discord. Once you introduce stuff like that, especially once you also do more stuff in the Lambda, I'm personally a fan of using step functions here, or you could also use the new Lambda functions, but I really like to have the ability to have it visually and to understand where certain conditions are happening. So this is the second step, adding a severity. The third step, in my perspective, is to make it even more dynamic. I think a CloudWatch alert or alert notification is only worth as much as you know what to do with it. And this is typically where runbooks come in. So what I really like is once this alert comes in, and if you imagine it's 3 in the night, you're not working, your support agent, your first level or second level support is taking over, he sees an alert and he has no idea what to do. Typically, I would say it is a really good idea to have some link to your runbooks in there where you describe what he should do in that case. And this is again where tags are coming in. We could define the responsible team, for example. We could say API, the responsible team for this alarm, and have an additional config to it. And this config could be simply saved in the systems manager. I really like that. So we could set up, this would be a bit of a manual approach, and in my perspective, it would depend on the person who's working with that or the team who's working with that. But the Lambda could also fetch the system manager config depending on which tag it has. And then we could have something like alerts API. So this would be the config for the API. We could have a default one, or we could have one for the project CRM. We could have different data. For example, we can say on rotation, the person who's on rotation. We could say runbook, URL, and even more. So you can define this however you need it. And this would make it even more flexible and more dynamic. So you can give more data into your system manager, read in this data, and then give it to Discord or handle it however you want. So I think these are the three things you should really do to take it a notch further, but I think the basic principle will be pretty clear in the repository once you deploy it and once you get an idea of that. The whole idea of centralized alerting comes not from me originally. We also followed a blog post here on the AWS Operations Cloud blog. It is quite nice to get an understanding. They are also proposing exactly the same thing. We have a sender account, which is the member account here, and we have some receiver observability account. And this is how we can set this up. So I put this into this as well and into the blog post because I think this is a great read to understand that. But I think it's even nicer to have some code with it and to see how you can deploy it. So all of that is centralized alerting for CloudWatch in AWS. Just to recap, you have a management account with a CloudFormation StackSet where you deploy a rule into your app accounts. The app account basically just forwards an event to the observability account, and in the observability account you can do whatever you want with this event. But the idea is to really, your developers shouldn't need to think about how to connect to Slack, how to connect to Discord. They should really just think about building the application and running the application, and after that everything is set up automatically. The full code is on GitHub. I've linked it down below as well. I hope that helps you, and let me know what you think. Thanks.